lesson is about factoring quadratic expressions. Before we start, though, we're going to go back and review how we multiply binomials, and we use a process called FOIL, which stands for multiply the first term times the first. So it would be x times x, which is x squared. And then we multiply the outside terms, so that would be 2x. And then we multiply the I stands for the inside terms, which would be 4x. And then we multiply the last terms in each binomial. So 4 times 2 gives us 8. And then we simplify that, so that would be x squared, and combine like terms. So 2x and 4x would give us 6x, and then we have 8. So that is a trinomial. Now, the factored form then is x plus 4, that quantity, times the quantity x plus 2. And what we need to understand is how this relates to this. So first of all, the first term, that came from multiplying the two first terms here. The last term, that came from the product of the 4 and the 2. This middle number right here, that came from when we found the outer and the inner and added those together. So the outer and the inner, we add those together. So those numbers that we added together, the 4 and the 2, those are the factors of 8. So using that, we are going to factor this expression, x squared plus 14x plus 40. So we need two sets of parentheses here because we're going to have two binomials. The first term, remember, that comes from multiplying the firsts of each binomial. So x times x gives us x squared. The last term, well, the last term in each, that will come from the factors of 40, or one pair of the factors of 40. So let's list the factors of 40. 1 times 40, 2 times 20. You need to just go through and make a list of them. And if you don't know them offhand, just start at 1 and go through the numbers. And you can divide into 40. So does 3 go into 40? No. Does 4 go into 40? Yes, 10 times. Does 5 go into 40? Yes, 8 times. Does 6 go into 40? Not evenly. Does 7 go in there? No. Does 8 go in there? Yes, and we've already listed it. So that tells us that we have all of the factors right here. Now, remember, those factors, those numbers have to add up to 14. So we look for the pair that add up to 14. So that would be 4 and 10. And it needs to be a positive 40 and add up to a positive 14, so those signs are both positive. And if you just multiply that back together, you can FOIL it back together, and you will see that it gives you your original equation. Here's another one. So x times x gives us x squared, and now we want factors of 20, and they have to be factors that add up to 9. 2 times 10, 3 doesn't go in there, 4 times 5. And so 4 and 5 will add up to 9, so we'll use those. And they're both going to be positive because 4x and 5x, the outer and the inner, would add up to 9x. Now let's look at the next one. In this one we see it's a little bit different because there's a negative right here. We still have a positive 27, but remember with factors, two positives, a positive times a positive gives you a positive, and a negative times a negative will give you a positive. And two negatives add up to a negative, so we're going to want to put negatives for both of these. So the factors of 27 would be 1 times 27, 3 times 9, and I think that's it. So now if you look at these, which add up to 12? Well, 3 and 9 do, and minus 3 and minus 9, oops, I wrote that wrong, that would give you minus 3x minus 9x, that gives you your minus 12. And if you take a negative 3 times a negative 27, that's a positive 27. Let's try it again. Factors of 72. Let's list those. That has a lot of great factors. 3 times 24. 4 times 18. 5 doesn't go in there. 6 times 12. And 8 times 9. So now we want the factors that would add up to 27. So 3 and 24. But they both, if we look at this, the outer is 24x, the inner is 3x. They both will have to be a negative because negative 3 and negative 24 gives you negative 27. All right, now this is different because, because now we want a negative 72. We get a negative when you're multiplying, you have to have one number be positive and one be negative, which means when we're putting those together, we're subtracting to get a positive 21. So let's look at that. Let me list my factors quick. All right, so now which of those could we subtract to get 21? Well, 3 and 24, it looks like we will be using those again. So if we look at the outer, that's 24x. If we look at the inner, that's 3x, and we want to get a positive 21. So we would put a negative right here because 24 minus 3 gives you 21. So the negative has to be in front of the 3, so that would be negative 3x and a positive 24. And then now look at your last. When you multiply the last number times the last number, negative 3 times positive 24 is a negative 72. So let's do this next one. X times x, and again, it has to be a negative 42, so one sign will be positive, one will be a negative. So we'll list the factors of 42. Let's see, 3 times 14, I believe. 6 times 7, I think that's it. So 6 and 7, and let's look at the outer and inner. 6 times 7 is 42. The outer is 7x, the inner is 6x, and we would want to have a negative on the 6 because 7x minus 6x would give us the 1x. So negative here, so we have negative 6x, positive here, so we have a positive 7x. All right, x times x, factors of 45, list those out. 3 times 15, 5 times 9. And the ones that would have a difference of 4, because since this is negative, one's positive, one's negative, so we're going to be subtracting, would be the 5 and the 9. And so if we look at the outer, that's 9x. We look at the inner, that's 5x. Which one are we going to put the negative in front of? We would want to have a negative 9. Because 5 minus 9 would give you a negative 4x. So positive in front of the 5, negative in front of the 9. Let's try another. So we have x times x, the factors of 30, 1 and 30, 2 times 15, 3 times 10, and 5 times 6. And the ones that have a difference, the factors that have a difference of 1 would be 5 and 6. So let's look at this. We have the outer is 6x, the inner is 5x. We want a negative 1x, so we would have a negative 6. 5 minus 6 is a negative 1. So negative and a positive. All right, here's another problem. Now this one, notice it starts with a negative, and those can be harder to factor. So what I usually do is I usually factor a negative 1 out of every single term. And when we factor, we are dividing out a negative. So negative x squared divided by negative 1 would be a positive x squared. 14 divided by negative 1 is a negative 14x. 32 divided by negative 1 is a negative 32. Now realize this statement here is equivalent to this one because if we distributed the negative 1 back through, it would be the same as this. So as we factor, we always want to have equivalent statements. So the negative 1 needs to stay out front. Now what we're going to do is factor this. So we have x times x, factors of 32. Lots of times students don't like to write these, but it definitely helps. So I really encourage you to do that. So those are factors of 32, which have a difference of 14, would be the 2 and the 16. And so 2 times 16 is 32. One has to be positive, one has to be negative because you have a negative 32. So again, your outer is 16x, your inner is 2x. If we want a negative, we're going to put the negative on the larger of the two numbers. So 2 minus 16 would give you a negative 14. So minus 16, positive 2. And that is your answer. Now we're going to be factoring out the greatest common factor, and that is the common factor of the numbers with the greatest coefficient factor and the greatest exponent found in all of the terms. So we're looking for the greatest common factor. So here we have a 6 and a 6. So 6 is the greatest common factor. We're going to factor that out front, and we want to look at what is the highest exponent that is found in both of them. Well, the exponent here is just a 1, and so that's the highest exponent found in this one, so that's what we're going to use. So when we factor, we are dividing. So 6n squared, I'll write this down over here, divided by 6n, well, the 6's cancel, n squared divided by n, we could cancel out 1, so we have just n left. Now if we take 6n and divide that by 6n, everything cancels, so it's equal to 1. So this would be plus 1. This is your factored form. So if we were to distribute this back in, we'd have 6n times n, which is 6n squared. 6n times 1 is 6n. So that is our factored form. Now if we look at this next problem, what is the greatest common factor of 7 and 21? It's the greatest common factor that they both share. Well, that would be 7. So we can factor out a 7, and we can factor an n out of each. So 7 divided by 7 is 1, and then n squared divided by n is n, minus 21 divided by 7 is 3, and if you take the n out, that's gone. So it would be 7n times n minus 3, and you can distribute that back in, and it would equal the same thing that you started with. So in a problem like this one, you could just start out by factoring with the binomials, but it's going to be easier if you look for that common factor and take that out. Well, there's a factor of 4 in every number here, or in every coefficient, I should say. So 20 divided by 4 is 5, and 56 divided by 4 is 14. So now we factor and continue bringing that 4 down, because you would have to multiply through by that 4 to end up with your original, and it has to be equivalent. So the factors of 14 are 1 and 14, 2 and 7, and the factors that have a difference of 5 would be the 2 and the 7. And if you look at your outer and your inner, you want to have a positive 5, so that would be 7 minus 2. 7 minus 2 gives you the 5. Here we look for a common factor, which would be negative 9. Remember, if it starts with a negative, take that out. So negative 9 divided by negative 9 is a positive, and that would be x. 18 divided by a negative 9 is a negative 2. And so now we factor. So x times x, the factors of 2 are 1 and 2. And if we want to have a positive 1x right here, we would have a plus 2 minus 1, because 2x minus the 1x gives you 1x. Next problem, we're going to factor out of 4. And we'll try to factor again. So we have x times x, and everything, both signs are pluses, so we know this has to be a plus right here. 1 times 3 gives us 3. Now let's just double check that. 1x and 3x. Well, that 1x and 3x, that does not give us 2x. And we can't put a negative in, because if you have a negative, you'd have a negative 3 here, so that doesn't work. So this problem cannot be factored any further than this right here. This would be your most simplified form here. So let's just do a couple problems here. Like in this problem, you look for your greatest common factor. Well, it would be a 3. So if you factor 3 out of the first term, you would have a squared left, and 9 divided by 3 is 3. In this problem, if we factored out the greatest common factor between 25 and 20, that would be a 5, and then we could also take out a b. So we would have 5 25 divided by 5 is 5. And if we take out a b, we would just have a b there. And 20 divided by 5 is 4. And if you take out the b, you would just have that 4 left. All right, now we're going to talk about factoring in a quadratic equation when the a value is greater than 0. So like here, we have a 5 in front. So that's going to change what we're doing slightly in that our first term is going to have to equal 5x squared, so we'd have to have 5x times x. So when we do our outer and our inner, we're going to be multiplying by 5 in that outer term. So again, we'll list the factors of 6 because we know the last two have to multiply to equal 6. So, and now what we do is we're just going to try all the combinations. For example, if we do 1 and 6, when we look at the outer and the inner, that would be 1x and 30x. There's no way we're going to get 17 out of that. So we will change those to 6 and 1. So that would give us 6x and 5x. That will not give us 17. So we know that the 1 and the 6 don't work. So now we'll try the 2 and the 3. So if we do 2x and 3x, that gives us 5x and 2x. That did not work. So let's, oopsie, I wrote this wrong. This should be 2 and 3. How about that? So that would be 15 and 2. There we go. Now we're talking. So 15x times 2x. And if we make them both negative, they would add up to negative 17. And then if we look at our last, negative 2 times negative 3 is 6. So that would be how we factor that problem. All right, let's try another. So we have to have 3x squared. So 1 will be 3x, 1 will be x. Now, the last terms are either going to be, let's see, the factors of 7 are 1 and 7. So it's either going to be 1 and 7 or 7 and 1. Well, we need to get around 20. So 3 times 7 is 21. So we'll do this. Now, if we look at our outer, that is 21x. The inner is 1x. And 21 minus 1 would give us 20. And negative 1 times 7 gives us negative 7. And we'll do another. 5x times x, and 3, it's either going to be 1 and 3, so we'll try that. Well, that's 15x and 1x. That did not work. We'll switch those. 3 and 1, that would give us 5x on the outside and 3x on the inside, which is 8, and that's not going to work. This one cannot be factored. All right, let's try another one. So this time our a value is 4, which is an even number, and it has more than one pair of factors because the factors of 4 are 1 and 4 and 2 and 2. So we will need to try both sets. The last number is 5, so we know that that can only be 1 and 5 because the only factors of 5 are 1 and 5. So let's try the 1x and 4x. And again, we have to look at what does the outer and what does the inner give us. Well, that is 9x, which we can't get a 12 out of that. So 1 and 5, they need to stay in the same place. So let's switch the 4 and the 1. This is easier to do on just a erasable whiteboard than on this whiteboard. So in this case, that gives us 20 and 1, and that's not going to give us 12. So we know that 1 and 4 are not the beginning factors. So let's erase a little bit here. All right. So then let's try 2x and 2x, and we knew that the last ones had to be 1 and 5. Well, that would give us 10x and 2x for the inner, and 10 and 2 add up to 12 for your middle term, so that would be your factorization. Let's try another. So again, we have either 1 and 4 or 2 and 2. So let's try 1x and 4x, and 1 times 2 is 2. Well, that would be 2x and 4x. Does not work. Won't give us 9. So now we'll try 4 and 1 right here. So that would give us 1x and 8x. That works. Let's see, but does it work? We have to think here. That gives us 9, but can we get a negative 9 out of that? Because one has to be positive and one has to be negative. Nope, they both have to be negative, don't they? Because negative 1 and negative 8 gives us negative 9, and negative 1 times negative 1 gives us a positive 2, so that works. Now, in these problems, these are called perfect square trinomials because if you look at the first term and the last term, they are perfect square numbers. Look here, first term and last term, perfect squares. First term and last term, perfect squares. These are really nice to factor if you recognize that the first and last term are perfect squares. What you do is for the first, you write down the square root of 9 in this case. So 3x and 3x. And then what number squared is 16? 4 and 4. All the signs are positive in this problem, and so those will be positives. Now take a look. Your outer is 12x, your inner is 12x, and that will give you your 24x in the middle. Let's try another. This time we have to watch our signs. So 8x and 8x. 8 times 8 is 64. 1 times 1 is 1. And now we have a positive here, which means it's either two positives or two negatives. So it'll be negative because negative 8x and negative 8x gives us negative 16x. Now this one we have to be a little careful for because as we look here, there is a common factor of 4. And so we should take that out first. That would give us x squared minus 6x plus 9. Now notice we still have a perfect square trinomial because 1 is a perfect square and 9 is a perfect square. So that would be x, 3 times 3 is 9, and minus 3 is minus 6. Now let's say you didn't notice that that 4 was the common factor and you just factored this as it was. Well, if you did that, you would say, well, the square root of 4 is 2. So you'd have 2x and 2x. The square root of 36 is 6. So you'd have 6 and 6. And 12x and 12x, they would both have to be negative to give you the negative 24. But remember, when we're factoring, we have to factor until we take out all the common factors. So here, we would have to take out a 2. So we would have x minus 3. And if you have a 2, out of this one, you would have x minus 3. And 2 times 2, we can combine those to write 4, and you'd have x minus 3, x minus 3. So eventually you do have to factor out that 4, but if you didn't see it at first, it would just be one extra step that you would have to go through and factor it out at the end. All right, now these are called the difference of two squares. So again, here you have a square and a square, but notice there's not a middle term here. And you're subtracting the squares, so that's why it's called the difference of two squares. And these are kind of neat too. 25 is 5 squared, so 5 times 5, 5x and 5x will give you 25x squared. 7 times 7 is 49. And here, whenever you do the difference of two squares, one sign's a plus, one sign's a minus. See, look at if we FOIL this together, you would have 25x squared. The outer is minus 35x. The inner is plus 35x. And the last is minus 49. Look at your middle terms. They go away. So that equals 25x squared minus 49. So that plus and minus, that is what gets rid of your middle term. So here, difference of two squares. So 4x and 4x gives us 16x squared. 9 times 9 is 81. 1 is a plus and 1 is a minus. And the next one, oh, no, we have, we can take out a greatest common factor of 4 actually again in this case. So it's 25x squared minus 16. So the 4 just stays out front. Now again, you have the difference of two squares. So 5x times 5x, 4 times 4 plus and a minus. And that is it for this lesson. Let me know if you have questions. Thanks for watching.